esteemed guests today. Good morning. Thank you for joining us on this very important session. As we all know, that's India AI Impact Summit 226. It's a global inflection point for all of us. And we all would agree that these 5 days will be history in the making for all of us. And it's so proud feeling to be part of this history. Without wasting any more time, I'll request the speakers for today's first session, which is Generative AI and Future Networks, to come on the stage. I'll request Sri S.T. Abbas to please come on the stage. Sir, put your hands together. Next, I'll invite Sri Shyam Madikar to be on the stage, please. Thank you, sir. We'll ask Mr. Gurvinder Singh Ahluwalia. He is CEO Digital Twin Labs USA. So please be on the stage. Next, I'll invite Mr. Manoj Gurnani from Nokia. Yeah, thank you, sir. Please be seated. I'll ask Mr. Colonel P.K. Chaudhary to please be on the stage. And yes, ma'am, Janet White, please be on stage. Thank you very much, ma'am. So as you can see, the kind of speakers you will see today, this is the power packed. It's a global speakers we have the privilege to have today. I have a privilege to call Sri Anil Kumar Bhardwaj ji for giving up the welcome address. As you all know, Bhardwaj ji is a regulatory specialist, over 30 years of experience in leadership roles in policy regulation, economic policy, competitive regulation, and change management. And we all know that he has been advisor to TRI also. So put your hands together, Sri Bhardwaj ji, for your welcome address. Thank you, sir.
Thank you, Dhananjay. Dignitaries on the dais, Shri S.T. Abbas ji, Shyam Madikar ji, Gurinder Singh Ahluwalia ji, Manoj Gurnani ji, Mr. P.K. Chaudhary, and of course, our friend from GSMA, Janet, and ladies and gentlemen. This session has been curated on behalf of DOT. Actually, I first of all want to welcome you all and thank you for sparing your valuable time today morning. Whatever AI, and AI is changing the world. We all are hearing, we are listening to things, and there is a tweet of Matt Schumer which became viral 3 days back. We are actually living in such times. But what is making such time feasible is, in addition to innovation, that is the underlying networks and the underlying cloud centers, data centers, and today they are becoming one. The boundaries are blurring. In fact, there are no boundaries. Today, the agentic AI, when it takes over, it travels across the networks and traverses and talks to agents, start talking to each other and make things happen. And they are making things happen in real time, much more efficiently than what we humans could do. It's same as calculator does the calculations much faster. So the world is changing, and I thank you and welcome you on behalf of DOT, Department of Telecom, once again, and thank these speakers. In these speakers, we have word of experience. We have people who are managing this change, people who are actuating this change, people who are looking at global picture, what this change is bringing. And believe you me, all of us have to understand that unless there is an underlying network, all this agentic AI will not mean, or all these AI innovation will not mean what they are required to mean. And that is where we come through, and that is where this topic of generative AI and the future networks. So happy listening, and once again, welcome to you all.
Thank you, Anil sir. Yes, he has set the tone for the session to start. I'll request my colleague Supratik to take it forward now. Thank you.
Thank you, sir. Good morning, everyone. Our first speaker of the day is a distinguished ITS officer with extensive experience across Indian telecom ecosystem. Over his illustrious career, he has held key leadership roles in MTNL, the Department of Telecommunications, where he has contributed significantly to carrier services, data services, and telecom policy research. Sir has also served at TRI as advisor and principal advisor on network spectrum licensing. His deep expertise in telecom policy and spectrum management makes him a highly respected voice in the sector. Ladies and gentlemen, with a huge round of applause, please join me in welcoming Shri S.T. Abbas, Senior DDG TEC, Department of Telecommunication. Thank you. Sir.
Distinguished co-panelist, esteemed audience, ladies and gentlemen, a very good morning to all of you. So it's my privilege to be here in this IndiaAI Summit today with this topic of generative AI and future telecom network technologies. So we are having distinguished panelists from the industry, and they are going to be telling more about how the AI is going to shape the telecommunication network and how the use of generating AI will benefit the telecom network with the network optimization and to the consumer services. So I have to just give a brief about how the traditional AI system were working till now and how the generative AI is going to transform the things in the coming time, in the coming future generation technologies. So the traditional AI system that is already working with the telecom network, and it primarily analyze or classify the data and gives the output which is currently now required, whereas the generative AI system that generates new outputs based on the pattern learned from the large data sets. So these models of the generating AI, they rely on advanced machine learning techniques and are trained on massive volumes of data to understand context, generate coherent responses, and perform complex reasoning tasks. So what is the difference between traditional AI, which is currently being used, and the generative AI, which will bring some additional features also? So the traditional AI has already proven highly effective in telecom environment. It performs well in structured, well-defined tasks, such as anomaly detection, KPI forecasting, traffic prediction, churn estimation, and predictive maintenance. These use cases rely on statistical learning, supervised or unsupervised models. And for many operational scenarios, also those requiring real-time reliability, the traditional AI remains sufficient and in some cases preferable. Whereas generative AI becomes particularly powerful when the tasks require contextual reasoning, synthesis of information, or interactive intelligence. For example, in root cause analysis, traditional AI can detect correlation and identify likely fault domains, whereas generative AI on the other hand can go a step further. It can interpret multi-source logs, generate human-readable summaries, propose step-by-step remediation workflows, and even simulate alternative scenarios also. Similarly, in customer support also, the traditional chatbots rely on predefined scripts and intent trees, whereas generative AI powered systems can handle open-ended queries, maintain conversational context, and generate personalized responses also. So generative AI can generate synthetic data sets for rare scenarios, create digital twins of network environments, and simulate network behavior under future demand conditions. So this relationship between generative AI and future telecom networks, it is going to be further broader, particularly in 5G Advanced and 6G, because these are the co-developing as mutually enabling technologies. In earlier generations, AI was introduced as an optimization layer, whereas the emerging 6G vision increasingly describe network as AI native. And this means AI is not simply an add-on tool, it becomes embedded with the architecture itself. AI models may influence control plane decision, spectrum allocation, resource management, and service orchestration. And these generative AI applications, they will be useful in radio access network as well as core network and provision of services also. In the RAN domain, generative AI can generate synthetic radio datasets, build digital twins of radio environments, and enhance channel state information prediction. The wireless physical layer foundation model of generative AI, this will enable the large-scale pre-training on radio datasets, improving beamforming, massive MIMO organization, and interference mitigation. And this reduces the reliance on costly drive testing and allows network to adapt more quickly. In the field of core network, generative AI supports automated policy generation, intelligent network, slicing, fraud detection, and advanced traffic modeling. And there will be a transition from traditional self-organizing networks, which depend heavily on rule-based mechanism, towards predictive, context-aware, and self-learning system. And further, collaborative inference architecture, which models are distributed between devices and edge nodes, help manage computational demands while maintaining strict latency targets. Such distributed AI processing will be critical in 6G environment. And so that is why TEC has initiated a technical contribution also to the ITU-T study group 13 on benchmarking framework for generative AI in telecommunication network. So the future network will accelerate the proliferation of Gen AI also. So AI will be helping the network, as well as network also will be helping the generative AI to process the data faster, because 5G Advanced and 6G provide ultra reliable, low latency communication, massive bandwidth, and integrated edge computing. So these capabilities allow generative AI models to be deployed closer to the users, enabling real-time immersive application, autonomous systems, and intelligent industrial solutions. So network slicing will provide dedicated resource for AI workload. So as communication, computing, sensing, and AI converge, the network will become pervasive platform for delivering the Gen AI services at scale. And at the same time, the security and trust challenges must also be addressed. Threats such as prompt injection, data poisoning, model inversion, adversarial manipulation, and privacy leakage can have serious implication in telecom network. Compromised AI decision could impact service continuity or even emergency communication. Therefore, a strong governance framework and secure model update mechanisms are essentially required for safeguarding the networks. So in conclusion, the relationship between generative AI and future telecom networks is deeply interdependent and transformative. Future networks, particularly 5G Advanced and 6G, will provide the high capacity, low latency, and distributed computing infrastructure necessary for generative AI to operate reliably at scale. So the success of 6G will therefore depend on how effectively we integrate generative AI into the network architecture while ensuring performance assurance, interoperability, security, and trust. Thank you so much.
Thank you, sir. As always, your insights are second to none. Our next speaker began his career at CDOT and later joined the Department of Telecom as an ITS officer before moving on to the industry, where he held senior leadership roles in network planning, engineering, and technology strategy. Sir has also served as the CTO of Lebara Group in London and was a member of GSMA's Executive Management Committee. Ladies and gentlemen, with a huge round of applause, please join me in welcoming the President and Group CTO Mobility of Reliance Jio, Shri Shyam Prabhakar Madikar.
Thank you. Can we have the presentation, please? Good morning. Thank you. Abbas ji, Janet, Colonel Chaudhary, Muir, and the gentleman from. It's a pleasure and privilege. Anil, thank you so much for hosting the DOT session. I think we do as the bandwagon of AI, bandwagon of compute, bandwagon of IT and semiconductors kind of get bigger and bigger and bigger. I think we also need to understand and highlight the pivotal and fundamental role that telecom as an organization kind of as an industry plays into it, because this becomes the baseline on which the whole picture is getting evolved. What I want to do over next 10 minutes max is actually take you through some fundamental paradigm shifts that are happening, and how are we as an industry, how are we as a country, and how are we as a planet actually kind of looking forward to it, and how is this going to change the way. How are we fundamentally going to use this as the next vehicle on which not only the citizen interactions, enterprise interactions, government reaching to its citizens, everything is going to happen. So let's start with the fundamental forces of this nature. We are talking about two fundamental forces. They are coming together now. Connectivity, which is growing by leaps and bounds. We are talking about a really incredible and unprecedented velocity at which connectivity is growing. Every 10 years you see a new generation coming in. We started in India almost now 4 decades back with 4G, with 2G, then came 3G, then came 4G. Now 5G is something which is out there, which is getting advanced, and we are right now on the anvil of moving to 6G. Satellite is there knocking at the door. Fiber is getting much more pervasive. So connectivity is indeed kind of moving at a really unprecedented velocity. That is the first force. The second force is compute. And if you look at compute, it has also, thanks to Moore's law, processing power doubling every year, which is almost 1,000 times every 10 years. How does it scale up from very basic capability of microprocessors to group processors to serialized chains of processors to now GPUs and TPUs and things like that, where the ability to synthesize, process and understand data is actually going again at an incredible velocity. And when these two forces are moving at these great velocities, the only currency they are using is data. There is just one currency. In fact, network and connectivity moves data from one point to another, and compute processes and synthesizes that data for output, for insights, for actions. Now is the time when these forces are actually converging to use this common currency called data, to take it to the extremely intuitive level, extremely aware level, where anybody or everybody, be it a human being or a machine or a process, is able to understand the data, process the data, connect it to the nearby adjacent and far-end systems, and draw insights and actions which were actually in the realm of science fiction as early as 5 to 7 years. I mean, before COVID, we could not have even imagined the way AI has used connectivity and has become this pervasive in our world of industry. Now, when these two forces by itself are so fierce, what happens if one starts complementing the other? If you look at what compute does to connectivity, compute makes connectivity aware, which is one of the biggest, single largest shifts which is happening in these new generations we are talking about, 5G to 6G. The network is aware of what is happening. The network is self-healing. The network is self-optimizing. The network is personalized. And the network is real-time. So the pipes were always there. But what compute has made them realize is these pipes can now be aware. These pipes can now decide. These pipes can now predict. These pipes can now automatically drive actions. And that is where the multiplier effect of compute and connectivity has come. Other way around, how is connectivity kind of driving the compute capabilities? So while compute makes connectivity aware, connectivity is making compute flow in the way it has never before. It is now flowing in your vehicles, it is now flowing in the devices, it is now flowing at the edge, getting closer to the customer. Again, inference is real time, not only computed real time, but also transmitted real time, but also acted real time. And that is where connectivity has aided compute to drive it to the next level. The intelligence is now distributed, and this distribution is on the hands and legs of connectivity, which is driving this apart. So if you look at the forces, one impact on another, other impact of other, actually they are not adding. It is not 1 plus 1. They are multiplying. It is a 10x syndrome that is happening the moment you see how connectivity is impacting compute and how compute is impacting connectivity going forward. And that is where this amalgamation of compute and connectivity, these two forces on the currency called data, is going to make us live the next decade, make us excel in next decade, and make the life totally different and totally pervasive of intelligence going forward. It is everywhere now. You're talking about individuals, we are talking about assistants that understand the context. We are talking about translation things real time. We are talking about accessibility real time. Smallest of jobs about booking, planning your travel, booking your air tickets, smallest of jobs around getting assistants schedule your things, getting assistants write email for you. It is right now available to every individual, and it is only, this is just the tip of the iceberg. I mean, the ability of individuals to use this AI in a connected world is only limited by their own personal imagination. Sky is really the limit, or even beyond. Now that's the individual context. If you move to the enterprise part, enterprise, and we've been hearing this about now 3-4 years on this Industry 4.0 concept. How do you brutally and deeply automate every action that an industry does? It could be a manufacturing industry, it could be a health industry, it could be education industry. The amount of value add this intelligence does on top of all processes, all capabilities, all supply chains, all assembly lines is unimaginable. And imagine this aided with market intelligence, aided with customer awareness for that particular enterprise. We are actually talking about workflows that will self-generate themselves, workflows that will self-create themselves and drive the fulfillment cycle to a totally different level of satisfaction to the end customer. So we're talking about individual, we're talking about enterprise, but most importantly, how does government, and we have Abbasji talking about how government is kind of drive this whole forum today, and this week is talking about how AI is going to help us as a country. But imagine the tools, imagine the value it gives in the hands of government. The digital infrastructure is already a humongous success story in the country. Digital payments for us, Digi Yatra is an example, Aadhaar card is one, your banking is all online now. I think these capabilities, I think we are any which way almost a decade ahead than rest of the world, even on developed countries of the world. Now imagine putting intelligence on top of it. Imagine putting awareness on top of it. Imagine making it inclusive for the citizens. Imagine making it available and accessible to the last man in the last village, in the last Gram Panchayat of the world. How is that going to kind of scale up the reach and the decisive capability of the government to make the citizens' life better? So if you look at all the three vectors, You and me as individuals, you and me as corporate citizens who are driving our own respective industries and companies, and finally you and me as Indians, we are taking it to the next level. It is going to multiply, it is going to drive it to the next level. The networks definitely have come of age, and I think, I mean, one of my favorite stories is how about these Gs came about. You're talking about every decade when we started with voice, moved to messaging, moved to data, moved to video. Now we are getting into a level which is so inclusive, which is so intuitive that there is a human AI harmony in the next generations to come. But this is not only the networks that have come of age. The AI now in the coming years is really, really coming of age. From basic compute to shared resources, now from recognition to intuitive, it is now actually merging, and where these two roads meet, the connectivity and the compute with AI and with the next generation of network, the only people to kind of gain is all of us as citizens, Indians, and as proud members of this industry which is shaping the world. Thank you so much.
Thank you, sir. I am sure your insights really carry a lot of value for everybody in the hall. Also, Shri Abbas has not only joined us in his capacity as Senior EDG TEC, sir is also the CMD of TCIL. And a request to the speakers, we are expecting the Honorable Minister at 11:30 in this very hall, so I'd request if the speakers can be a little mindful of time. Our next speaker is based in the United States. He's the founder and CEO of Digital Twin Labs, which designs and deploys strategic digital platforms. Previously, sir was the CTO of IBM North America for blockchain, IoT, and cloud. Sir was also nominated to the prestigious IBM Academy of Technology. Ladies and gentlemen, please join me in welcoming Shri Gurinder Singh Aluwalia, CEO, Digital Twin Labs.
Can you hear me okay? Thank you. There was a little bit of audio difficulty sitting in that corner. I hope everyone can hear me okay, including my co-panelists. The most profound change of AI is in the cost of predictability, which is coming down. But even more profound, and really the driver behind AI, is that everything can now be represented as a language. So our definition of language has been reinvented by AI. And I'll pass through a little bit about that. My thanks first to the Department of Telecommunications, to the entire team at CEO AI, and then particularly to General Kocher, who might have stepped away at the inopportune moment, and to Brigadier Soin. Thank you so much for inviting me as a speaker over here. Continuing in the theme of imagine, I will have you imagine something different. Imagine a child flying a red kite on a green field under the blue sky. A child flying a red kite on a green field under a blue sky. You heard my words, you heard my language, but what it created is a picture in your mind, right? You turned my words into pixels. I can represent a picture through language. Similarly, you can represent anything through a language, which is what AI is doing. I'm a computer scientist by training, and I come to you as a practitioner of deploying disruptive solutions, which is what I've done for the last 30 years, mostly in the US, but globally. And even though I'm a computer scientist, I lean on economists that might be amongst you to explain technology, because technology cannot explain disruption. And these are three corpus of knowledge which I personally lean to, and I find it useful to many in my audience and in my circle. And that is the theory of the firm, which basically explains why transaction costs, which is an economic phenomenon, has advanced disruption and advanced technology, of which we have illustrious co-panelists over here from the cellular industry, and we all know what that has done to the cost of communication and e-commerce and so on and so forth. The second author explains that these disruptions not only happen, but they are actually predictable. It's a dry book, but if you'd like, you can take a look at Carlota Perez, a Argentinian professor. And the third one is also a Nobel laureate like the first one, explaining something called institutional economics, and this is actually very powerful and most recent. It says that you can organize without organizations, right? You can organize without organizations. So the army, and I know there are many army soldiers over here, even though it is a very strong institution and organization, at the field when it's detached needs to organize its formations without central organizations in some cases. So the emphasis is on organizing as opposed to the organization. If we look at a few progressions, we've been through tabulating systems, we've been through programming systems, and we are now into intelligent systems. I'll speed through some of the slides in the interest of time. This one is a little bit more interesting, where we had a little bit of data, and it was simple, it was calculable, right? And we could do it mathematically through equations. Then it became more complex, but it was still calculable, and we continued to do it through algorithms and programs. Now algorithms and programming has run its limits. If you are designing an autonomous car connected to a network that has to make on-board decisions, you cannot possibly compute the number of permutation combinations, and the complexity becomes infinite. And that's why we now lean on data to find data to build the algorithms, and we lead into a world that is not programmatic, it's declarative, right? My simple example on a quick tangent on declarative is, if you want chole bhature, right? You just want chole bhature. You don't have to define the recipe of how to make the chole bhature, right? So you want to go from A to B, you put in the GPS address, and it just takes you there. That's not science fiction, it's basically how cars are beginning to drive now. So I'll skip this around, except for the end, which says, given the agent, meaning given like ChatGPT or Grok, you're given an agent, all it has to do is it has to look for the tools, the edges of the graph, and then it figures out what nodes to traverse through in order to meet your command, right? Human behavior is, by definition, declarative on what you want, and the technology should serve that to you. Satya Nadella, the beloved CEO that India produced and is there in US, but I think he's around here now, basically said that the application layer is collapsing into agents. And the cellular industry and the application industry saw, as the infrastructure shifted, the application and the nature of applications also shifted. What does this mean? It means it's moving from imperative to declarative, right? Graphs are moving to be non-deterministic flows, and generation is retrieval. When we talk about generative AI, it is generative as opposed to what? It is generative as opposed to retrieval, like retrieving from a database. This is not something that exists in the database, which is how the past eras of computing. This is being generated now. The blue ones is of a little bit attention. The logic shift is from predictive to predictive neural networks to predictive machine learning and then to reasoning, and reasoning is then packetized for those in the network world, similarly as tokenization. So the flow shift is from data to tokens to process and then to predictive. So language is no longer just a communication. It is a representation of the physical and the digital world. It is a representation of our declarations. It is an expression. It is a thought. And more important to those of us in the networking and in the computer world, it is computation. Language can be computed. So I advance the sentence that everything is a language and language is everything. If we begin to understand this, we begin to understand that the era pioneered by Sun Microsystems, some of you might know that company, and I actually had the privilege of working for Sun Microsystems. They coined a phrase called the network is the computer. The network is the computer, and they pioneered that phrase in the 80s. And it is increasingly every few years and decades become even more true. So in that sense, the language, the network is also now the language. Text is already a language. Music is a sequence of MIDI events. Audio is numerically represented already. Images are represented as grids, as pixels. Video is images plus the sound, so on and so forth. You can take it to 3D models for DNA, molecular research, pharmaceutical, and so on. So I now come to how I started, which is when you visualize a child flying a red kite on a green field under a blue sky, you identified a who, you identified a what, you identified a field, you identified when, it's a blue sky, and you identified details of the color. We do that in our human brains, and machines are beginning to do that as well. Only because we are able to represent all these artifacts, not just text, but all these artifacts as a language. All right? So that's pretty much it. Everything is a language. Language is everything. And because all seeing is reading. So I tried my best not to talk as a computer scientist, and we begin to now see the impact of this expression of language, which has to be computable, not just by computers, but by the intervening networking intelligence. Thank you so much.
Thank you, sir. Ladies and gentlemen, we are expecting the minister here any moment. I'd request everybody to be seated even after the speeches are over. Our next speaker, he's a business technology leader with 30 years of experience across Nokia, Ericsson, Siemens, Reliance, Corient, and RFS. In his current role as the CTO and head of strategy at Nokia, he shapes technology vision and strategy for the India region, driving 5G and 6G adoption, next-gen technologies in telecom, spectrum readiness, and ecosystem development. With a huge round of applause, please welcome Shri Manoj Gurnani.
Hello, namaste everyone, and good afternoon. Time is limited. When we talk about AI, the first thing which comes to your mind is algorithms. And when you talk about AI in India, the first thing which comes to your mind is the scale. Scale of 1.4 billion population, 1 billion broadband customers, diversity, 22 languages. So, I mean, India is like a sandbox. So something if works in India, it's going to be a guarantee that it's going to work very successfully in all parts of the world. I'm going to touch upon few points which are related mainly to the networks, because that's the area where I come from. So the first thing is connectivity, which is pretty obvious, which so much of AI tsunami and the digitalization which we are all witnessing. The good news is that network will be at the center stage. There is huge focus on the connectivity. the connectivity, of course, will transform from connecting people in the 2G to the broadband to the connecting devices to what we call it as connecting intelligence. There are huge amount of trends which are emerging. We believe first, of course, is going to be the volume of traffic. The volume of traffic with the onset of AI is going to be humongous. I mean, we forecast that the impact of AI alone will lead to a bump up of almost 30 to 40% of the traffic in the mobility side alone. That's the first impact. And are we ready to actually cater to this kind of a network? The second is this kind of network is highly bursty, highly unpredictable. And from the download heavy, it becomes more upload heavy. So these are the trends which the networks will have to really focus on. And therefore, the broad philosophy in the connectivity is that you have to come to the paradigm where networks can sense, networks can act, and networks can adapt. So that's the first part on the connectivity side. The second aspect, which is pretty obvious, is the autonomous networks. The good news is that when 5G came and when 6G arrives tomorrow, the data availability in terms of the structure of the data, the quality of the data, the volume of the data, that's already kind of available. And the AI-assisted operations are used in a big way already for the past 3-4 years, be it your traffic forecasting, be it your network operations, which Shyam already talked about, be it the normal autonomous actions and the use of AI agents in the network operation. That's already happening in pretty much a big way. But what will actually happen is, with so much of autonomy, you will actually face the challenge of what we call it as black bodies syndrome, which means that if you provide so much of autonomy to the networks, a stage will come where you don't know that for any action, do we have any accountability? I think that's one part where we have to be very cognizant of, especially in the mission critical networks. And telecom today is not the telecom network, it's actually a critical infrastructure. So autonomy is going to play a big role simply because you cannot do the operations the traditional way. The volume of traffic, the plethora of technologies like from 2G, 3G and going all the way up to 6G, the amount of spectrums which we have, the amount of diversity which we have, all this is going to make it very, very difficult. So the use of AI in operations is something which is absolutely very mandatory. But to what scale the autonomous or the autonomy can be achieved is for us to see. I think I'll leave with the last message, which says that the autonomy, you should actually have the manual override. I think that's very, very important. I think the human angle, the strategic oversight, I think that should not be left. The third aspect which I'd like to talk about will be sustainability. And as telecom, telecom as an industry contributes maximum after the aviation. We would have done great in terms of developing the technology in trying to reduce the energy per bit. We have made rapid strides. A lot of work has been done. But despite that, the CO2 emissions have increased. And the two reasons are the volume of traffic has increased, the densification of the networks in terms of plotting more base station has increased. So when 6G arrives, we have taken a very ambitious target that, hey, can we at least at the network level reduce the energy consumption by half? That's a very ambitious target. So on a baseline of 2019, can we reduce the energy at the overall network, given the volume of the traffic, given the densification, can we reduce it by half? I think that will be a real contribution which the technology has to do. The good news is that AI as an application is being used in a pretty successful way. I think there are energy savings applications which have yielded 15 to 20% of energy savings. But this AI is sitting at the top of the network. Going forward, we have to move the AI native way, which means we have to devise the products and the technologies to make them AI native in true sense. In the end, for a country like India, I would say that there are 4 things we should be doing. We should actually look at devising responsible AI frameworks, and I think rapid strides have been made in that direction. The second thing is that we have to have a robust data governance system. Again, I think the government has taken very, very good steps in that direction. The third is to have a solid collaboration between the industry, the academia, the startup, and the tech side. That's very important. We should actually move into a very, very harmonized world. With the current geopolitical scenario, there is a huge danger of fragmentation that should be avoided. Telecom is successful because we actually follow standards. And I think that's something which we should also do when we are when we are designing the AI frameworks. And in the end, for a country like India, we have to think about India first, and we have to come up with the models which think about the region, which are more vertical specific, which have more context. So with that, thank you very much.
Thank you, sir, for sparing your time and your valuable insights. Our next speaker was commissioned into the Indian Army's Corps of Signals in 1986. He brings over 4 decades of distinguished experience across defense, corporate, and academic domains. Ladies and gentlemen, with a huge round of applause, please join me in welcoming the Program Director of HCL Tech, Colonel P.K. Chaudhary. Sir.
Good morning, ladies and gentlemen. There has been a series of very informative talks by most eminent co-panelists who are here. My presentation or my discussion with you for next 15 minutes is slightly different. It's a purely communication theory and information system researcher's perspective on the employment of generative AI on network optimization. Because of the constraint of time, the topic given to me was generative AI and networks. So in 10-15 minutes, nobody can address that vast canvas, so I selected a small part of it, where AI is getting massive traction in the global computer science research community, and that is the how to use generative AI fruitfully for network optimization. So basically, I am working on a survey research, and some parts of that research is going to be presented to you in next 10 odd minutes. So can I have next slide? Can I have next slide, please? Yeah. So my aim is, okay, thank you. So my aim is twofold: to acquaint you with what is happening latest in the global research community about the network optimization by using generative AI, which we have been using so far using conventional mathematical models. Where does the generative AI fit in? And the second part is, while doing so, we will see a taxonomy of the tools and methods being employed. These are my twin aims of next 15 minutes of discourse with you. So we have been doing network optimization so far in all our wireline and wireless networks for 3 things. We estimate the environment. For that estimated environment, we allocate the resources. And after we have allocated the resources, we control and monitor it. This is what we do in optimization. Needless to say, there are very eminent experts who run mobile network. It is real time, very dynamic, and so forth. But the methods which are used are both non-convex, bi-level, and stochastic processes. Putting it very simple term, a non-convex optimization is like how do you design a aircraft wing? It has number of multiple optimal solutions. You see a mountain, if there is one valley, it's a convex solution, optimization. If there are number of passes to cross that mountain, it is non-convex. When we are talking about generative AI, we have to see how this thing is changing. So there are largely 2 types of generative AI models which the computer researchers throughout the world are employing. And while we are very familiar with the large pre-trained models like ChatGPT or Cloud AI or Anthropic, what we use, but let us not forget the first one which we have written is the generative diffusion model. It's like an artist making a painting. He puts some broad brushes on the canvas. It may appear random to you, but ultimately it translates to a very good masterpiece. So here what we do in diffusion generative AI, we put some random noise, make it Gaussian, and after we denoise it to extract the object of interest. So both of them are being used by using two methods. One is either people are doing one-shot optimization or a Markov decision process. Put it very simply, in one shot, each decision is made independently. And in Markov, we have a sequential decision-making process based on the last probability state. Both of them are being used. So, two types of generative AI, diffusion model and large pre-trained, using both one-shot and Markov process. We will come to, this is what is happening right now, and gradually people are making way for generative AI models to do such tasks. We will try to separate hype from the fiction. There is a lot of hype that generative AI is going to get deployed and going to do wonderful things, but there are real challenges. And real challenges is an understatement. People are struggling, so I will come to that in some time. But what has brought an urgency to the entire process of changing over from conventional mathematical models, either one-shot or Markov, to generative AI, is the advent of 6G standards, where it has been mandated that the optimization process will be AI ML driven. So there is no choice. We have to get into it. And from the hardware, heterogeneous interfaces, come to a software-defined world. So this is the urgency of doing so. I will skip the general part of the general diffusion model and large pre-trained. You must be aware of the many differences which are there. What we do is the four things, which is at the bottom of this slide. We optimize some variables, like say traffic demand, using some input parameters like latency or throughput to achieve an objective, using some constraints. So coming to the solution which is emerging in the present world is twofold. Generative AI in network optimization is being used as twofold models. One is as a solution generator. It reads the entire data and comes up with a one-shot solution. Or it is coming as a deep learning reinforcement model, where it takes sequence by sequence. Now both are able to do optimization to a large extent, but there are two challenges. The DRL policy in diffusion model is very successful, but it has got latency, because iterative steps are being taken to solve it. The large pre-trained models are having a lot of computational issues because performance cost is not matching up. So researchers are trying to solve it. What is ultimately happening? As late as 6th of February, this great researcher who has got more than 1 million citations, that MIT scientist Kim Hye, has published a paper which has created a lot of buzz. He has been able to solve the diffusion model latency problem by using something called drift model. So why I am saying, I will conclude by saying, there are lots of promises and lots of challenges. The research community is heavily invested in solving the challenges. AI is fast emerging. What I say today may not be valid 1 week after now, because new models are coming up. Such a heavy investment has been made in global market in AI that the failure is not an option. And the research community will emerge. Network optimization is the most viable, likely application, and we will succeed in doing so. With this, I will close, and thanks a lot to organizers for giving me a chance to share my thoughts.
Thank you, sir. We'll be joined by the Honorable Minister any moment now. I'd request everybody to please remain seated. And last but absolutely not the least, our next speaker, Her role entails providing public policy support for mobile network operators across the globe on telecom, on data privacy, spectrum policy, IoT, 5G, and competition policy. She is a former British Telecom director, where she held senior roles in the areas of strategy, portfolio management, product management, mergers and acquisitions, and IT. May I request Miss Janet White to kindly join us with a huge round of applause, please.
All right, I know we're very short on time and that a lot of the things that maybe I was going to say have already been said. So let's try and keep my comments short. First of all, though, I must say it's wonderful to be here in Delhi, a place where it really feels technology alive. When you walk through the halls here, you can feel it. It's absolutely amazing. So we meet at a time when the world is trying to understand what generative AI is and what it means for society. And what we see across markets, industries, and especially across the region is that AI is no longer something happening around our networks, it's something that's happening through them. Let me share a simple example. In one Asian market, after the latest wave of AI assistance became widely available, mobile operators saw a 10-fold jump in related traffic in just 1 month. An astonishing acceleration. This is not an incremental change, it's a shift in how people interact with digital services. And this is not an outlier. GSMA Intelligence estimates by the end of this decade, AI services could drive up to half of all additional traffic, fueled by multimodal assistance, generative content, and richer interactive applications. Put simply, AI is shaping the rhythm of our digital lives, and our networks are already feeling it. Nowhere is this transformation more exciting than here in India. India is emerging as one of the world's most dynamic digital economies, and that's not an empty phrase. GSMA analysis shows that Indian enterprises are projected to invest nearly 11% of their revenues in digital transformation through to 2030, far above developing markets average. And India ranks among the top 5 countries globally for digital transformation. India has shown the world what can happen when digital infrastructure and public purpose align, where through infrastructure, through Aadhaar, UPI, or the broader DPI ecosystem. And now, as India turns its attention towards AI, the country has an opportunity not only to adapt the technology, but to help shape its governance, its standards, and trajectory. So what do we need to get right? 4 things. Infrastructure that matches the moment. AI is pushing networks into new territory, higher uplink demand, tighter latency expectations, unpredictable traffic patterns. Future networks from 5G Advanced through to 6G must be built not just for capacity, but for intelligence, automation, and real-time responsiveness. Secondly, we need policies that support investment across the whole digital ecosystem. India and other countries has taken important steps to support digital infrastructure, including incentives that have helped accelerate data centers and cloud expansion. These efforts have strengthened the compute side of the ecosystem and created momentum for AI adoption. But the network layer often does not receive the same level of targeted policy focus, even though it's a network that ultimately carries the AI intelligence, the data, and the experiences that AI enables. This isn't about favoring one part of the ecosystem, it's about balance. A future digital economy requires end-to-end support, compute, cloud, data centers, and the mobile networks that connect them. Thirdly, trust and resilience. This was mentioned earlier. People will only embrace AI if they trust the systems behind it. Trust depends on cybersecurity, fraud prevention, responsible data practices, and governance frameworks that protect users while empowering innovation. Trust is not a nice to have, it's the foundation of a digital progress. And finally, openness and collaboration. AI networks, devices, clouds, and data flows are all intersect, and we've never seen them before. No single organization or a country can navigate this landscape alone. Progress will come from partnerships across sectors, across borders, and across digital ecosystems, whether through shared infrastructure, interoperable APIs like those supported by GSMA Open Gateway, or collaborative approaches to security and innovation. So, in closing, as we look ahead, I believe India has the potential not only to participate in the AI era, but to define it. The world is watching how India scales AI responsibly, how it strengthens its digital foundations, and how it ensures that growth is inclusive and impactful. And as generative AI converges with 5G, 6G, and cloud, India stands at a remarkable inflection point, with the opportunity to lead in a way that lifts the region and sets a global benchmark for the future of intelligent networks.
Ooh, that was an exciting session, I would say. Various aspects got covered, I think so, quite a breadth of it, a global perspective also. Thank you all for your speakers, for your insightful presentations. And obviously, thank you all for keeping it brief. We understand you would have thought to be going on and on, but so we'll request Director General CAOI, Lieutenant General Dr. S.P. Kocher to come on the stage and felicitate the speakers. So, I think so. Sri Abbas ji has already left us, so we'll start with Shyam Madekar ji. Thank you very much, sir. I'll ask Gurvinder ji to please. Thank you very much, sir, for giving us a global perspective. Next, I'll ask Manoj ji to please. Thank you very much, sir. Kalam P.K. Chaudhary. Thank you very much, sir. And yes, Janet ma'am, please. Thank you very much for giving your presentation, ma'am. We can have a group photograph, please. Sir. Sir, group photograph. A huge round of applause for everyone. Yeah, thank you. Thank you. And kindly be seated in the hall itself. The minister is about to come at any moment. We will have the pleasure of having interaction with him also. We'll also request the participant of the first session also to stay back. We'll have a photograph with the minister.